Hello, it's Ken again, and I'm producing some more booklets for Ruby, my great-granddaughter, to help her with her work at school. This is one of them I've done. And this one is perimeter and area. You can see they're not very big, just a few pages to help her revise her work at school. There are 14 booklets altogether so far. There will be more soon. And these are on my YouTube page, Kenneth Mallison, all one word. So if you're interested, have a look at them. This one is on perimeter and area, and so we'll talk about that now. Thank you. This is the index to the booklets I've written for Ruby. Quite a few different things in there. This one proves Pythagoras' theorem with the simple method. There's one more to go on here called power and energy, but it gives you an idea, and all these are on my YouTube page, Kenneth Mallison. So have a look. Bye. Before we look at this, can I just remind you that these booklets are for my great-granddaughter Ruby, who's 11 years old and in year 7. It's not a textbook. It's meant to be a guide to help her with her work at school, maybe when she does some revision later on. So it's not a textbook, it's just a guide. Well, here we go. Perimeter and area. When we talk about perimeter, we mean the distance around a shape. For example, with the square, the distance is 2 plus 2 plus 2 plus 2, which is 8 meters. For the triangle, we have 8 plus 6 plus 4, which is 18 centimeters. We can measure the perimeter of any closed shape. Now, this is meant to be all right angles. My drawing is not all that good, so it's a rectangular shape. Here we have a dimension. Now, this dimension I left out for Ruby to work out herself. So in this is 7 minus 4, which is 3. So we can start going round. Start here. We've got 7 plus 7 plus 3 plus 8 plus 4 plus 15 is equal to 44 meters. Now, it's a good idea, I think, to cross these out as you're going round. So when you get to the end, you can find if you've missed any off. Often people miss things off. This is an 8-sided figure, an octagon. It's called a regular octagon because all the sides are the same length. So in this case, the perimeter is just 8 times 3, which is 24 centimeters. For a circle, the perimeter is called the circumference, C. The distance across the widest part is called the diameter, D, and the distance from the centre to the outside is called the radius, R. Now, for all circles, the circumference is just over 3 times the diameter. I mean, you could check this yourself. Get a jar, measure the distance around the outside, measure the distance across, and divide them, and you get 3 in that sort of area. It's actually 3.142 and a lot more decimal places, and it's called pi. There's a symbol. Often we use a value of 22 over 7. If you divide 22 by 7, you get something like that. So the perimeter, or the circumference of a circle, is pi times the diameter. And as d is twice times the radius, we have the circumference is 2 pi r, which is the normal formula we use for the circumference of a circle. Here's a couple of examples. The circumference is 5 times pi, which is 15.71, or it's 2 pi r, which is 2 times pi times 2.5, which is again 5.71. Now, I usually point out to Ruby, it's very important to put the units down. It's no good putting down 15.71, because it could be 15.71 meters, miles, anything. Put down the units every time. That's what I remind you to do. Now, here's a problem. Problem 1. We need to find the perimeter, so all the way around here to here, the perimeter. I'm made of 2 parts. It's made of this bit here at the top, and this bit here at the bottom. The top bit is a semicircle, which is half a circle. So the circumference, or the perimeter, is half the circumference of a circle, which is a half of pi d, half of pi times the diameter, which is 20, which is 31.4 centimeters. The perimeter at the bottom is 20 plus 30 plus 30, which is 80 centimeters. So the total perimeter is 111.4 centimeters. What about this house? Well, we aren't given X and we aren't given Y, but we can work it out. The perimeter is Y plus 1 plus 5 plus 5 plus 1 plus Y plus X. And X is that distance here, which is 8, minus those 2 bits, 2, which is 6 centimeters. And Y is just 8 minus 3, which is 5 centimeters, which gives us a perimeter of 28 centimeters. Here's a problem. Can you solve this? Can you find the perimeter, which is this bit all the way around this figure? The radius is 4 centimeters. I'll leave that for just a second while you think about it. If you want to pause this page while you do it, you could do, but I'll put the solution on the next page. So I go to the next page. Here's the solution. The perimeter of the circular part is 3/4 the perimeter of a circle. So it's 3/4 of 2 pi times r, which is 18.8 centimeters. The 2 straight sections are just 2 radiuses, which is 8 centimeters. So the total is 26.8 centimeters. Now the area of a shape is measured in square units, centimeters squared or meters squared. Here's an example of a rectangle. A rectangle has a base of b and height of h. The area of a rectangle is just the base times the height. So if b is 4 centimeters and h is 12, the area is 48 centimeters squared. The triangle, in this case half a rectangle, is just half of that, which is half base times height. So the area of a triangle is the base times the height divided by 2. And here are 2 examples. There's a triangle, a base is 6, the height is 12, so the area is 36 centimeters squared. Another triangle here. In this case, you take this as the height. So the area is 4 times 9 over 2 is 18 centimeters squared. For a parallelogram, the area is half the sum of the parallel sides times the height. So if A equals B equals 8 and H equals 6, the area is 8 plus 8 over 2 times 6, which is 48 centimeters squared. Now, how about a circle? Well, in this circle, I've got 12 segments. So I take this segment out, that, I've got a side which is there, C over 12, 1/12 of the outside, and then that side there which is the radius r. Now we could take these segments, put them like this. So I move that segment into there, like so. We have 1, 2, 3, 4, 5, 6 segments there, and 1, 2, 3, 4, 5, 6 segments there. So this side is 6 times c over 12, which is c over 2, or half the circumference. And so it's that side, half the circumference. If we take lots and lots and lots of segments, arrange them, and then take this bit at the end here and put it at this end here, we get a shape like this. But this is c over 2, and that's r. So the area of a circle is like the area of a rectangle now, which is just c over 2 times r, or cr over 2. But we know c is 2 pi r. So we've got 2 pi r, which is c, times r over 2, which gives us pi r squared. Now that's the important bit to remember. The area of a circle is pi r squared. And here's an example. The area is pi times 3 squared, which is 28.3 centimeters squared. Back to this problem we had before, same shape. Now we need to find the area, not the perimeter. And it's made of 2 bits, the area of this plus the area of this. The area of this semicircle is half the area of a circle, which is a half pi r squared, where r is 10 centimeters, which gives us 157.1 centimeters squared. The area of the rectangle is just 30 times 20, which is 600 centimeters squared. So the area of the shape is those two together, 751.1 centimeters squared. Well, here's some problems for you. Remembering that my drawing is not very good, these are all right angles, it's a rectangular section. And down here, this is meant to be a right angle as well. So find this problem, how much fencing does she need? In other words, what's the perimeter of this shape? And down here, find the area of this shape. And this one here, question 3. Each of the squares is 1 centimeter square. What's the perimeter of the shaded area? And as an extra question, what percentage is this perimeter of the total grid? So find the perimeter and find that as a percentage of the perimeter of the whole grid. Question 4, may be too hard, but it probably won't be, but it may be too hard. But you've got to find a perimeter, which is this bit plus that bit. Now, remember that the number of degrees in a whole circle is 360. Actually, I've made it quite easier with, look at the diagram, and it should be easier to do. Question 5, what would be the area of Rubik's field? And question 6, what's the area of this shape here? Now I've put the solutions, sorry, not the solutions, but the answers to these problems on the next page. So it might be a good idea to pause this. If you want to do these, pause this, do the problems, and then check the answers to the answers on the next page. But here's the answers anyway. There's the answers. Now, this surprised me. So I did check it several times, and it is right. So there's the booklet I've done for Ruby on perimeter and area. I've also got one on a volume, which is the next section. So I hope you enjoyed watching this. I hope your children find it useful. If you liked this, then please tell your friends. If you didn't like it, then just tell me, and perhaps you can tell me why you didn't like it. But remember, it's for children, 11-year-olds, not necessarily for adults, unless they like to watch it. Bye for now.